Hi folks, this is Dr. Nielsen-Pincus and I'm here with a video tutorial designed for lab assignment number 3 for ESM 335, focused on Portland's air quality and demographic characteristics. So you can see here I've got the lab assignment 3 opened up here, and I'm just going to scroll down past the assignment description, which we've already discussed in class, and straight to the worksheet here. So you can see the first question in the worksheet is designed to have you understand the distribution of each of the elemental contaminants that was tested for in the Forest Service's MOS air quality data set. And so basically what we want to find out here is the range, the average, and the skew, and the number of samples with detectable measurements for each of the 22 elements measured in the data set. So to do that, I'm going to jump to the data set. So here we are. You can see it's opened up to the README. That'll tell you a little bit more about the data. We've got the metadata tab here on the second sheet. So you can see here are the list of the 22 elements the data was collected for, and the metric in which, or the units in which the data is recorded in. You also notice up here that when you see a period, that indicates values that are below the detection limit. So we're going to hang on to that idea for a moment. So we can go to the actual data itself. So here we are on the data. I'm just going to go all the way down to the bottom by pressing Control and the down arrow on my keyboard. Notice that I've frozen the top row here, so as I go down, the top row will stay there, and you can do that on a PC or on a Mac. Just use the little help section on the map to figure out where it is. But on the PC, you can do it by view and freeze pane. And if on the PC, if you highlight the row you want to freeze, then you can just say freeze top row, and that'll hold it there. On a Mac, it's a little bit different, but you'll figure it out. One thing to note is on a Mac, I believe you have to freeze the row below the one that you want to freeze. So here on a Mac, you would freeze the second row. Anyhow, I've already frozen it, so I'm going to go to the bottom of my data set. I just pressed Control and the down arrow to get to the bottom. And you'll notice here I've just inserted over here a couple of things, pieces of data that I want to collect. And I'm going to add number of samples to that, because our assignment asks us also to get the number of samples with detectable measurements. So to do this, relatively simple formulas. I don't need to go into it in too much depth, I don't think. I'll just start with manganese here. You could start right here on the far left of the elemental data, do it for the first 4, and then use your fill handle to just drag and update the formulas for all 22 elements. I'm going to use the manganese because it's the element that's used for the example for the second question. So we'll start there. So we can say the range is going to be, the range goes from the minimum observation to the maximum, so that's how we're going to calculate that. So we can just say equals min, open parentheses, I'm Control and Shift. I'm going to select all the way up to the top. I'm releasing the Control and holding the Shift, and then the down arrow 1, and that gives me the full range of the data that I'm going for here. I could have also typed in P2 to P345. So equals min in that range. That'll give me the minimum value. We can then say equals max. I'm going to do the same here. Control Shift up, and then holding the Shift but releasing the Control, the down arrow. Now I've got the entire range of the data there. So the range of our data is from 18.2 to 449.8. The average equals average. And again, the same thing. We've got our average. Skew is just equals skew. Same deal here. And then we're going to say the number of samples. So equals, we know we have 344 observations. So we could just do 344 minus count if. We're going to give it that range again. We're just going to count the number of observations that were not detectable. and I put the period in quotation marks so that Excel knows that it's not looking for a decimal or a number, but actually the text of a period. And so we have 344 samples in here. So we're going to do that for all of our elements, and we can highlight these values, and we can drag them to the right or drag them to the left to update for each of the other elements. Okay, so now you'll notice that the minimum value, the bottom of our range, is 18.2. Hold that thought for a moment. You need to interpret the results that you got from that and tell a little bit about how you did it. But then we can move on to question 2, which is to create a histogram for each of the top 4 elements with the greatest skew, and identify on the histogram which samples you think most likely indicate pollution sources. So creating a histogram is our task here, and so to do that, I've created a sheet in the Excel data set that has an example histogram using manganese data that we just looked at. Just notice the hints here. Please have at least 20 concentration bins on the x-axis. We'll look at what that means here in a moment. So let's go to the data. So you can see the min in our range is 18.2. If we go to the example histogram sheet here at the bottom, you can see we have our histogram example set up here. I just have the min, the max, and what I've done here is taken the maximum minus the minimum, that's the total range of our data, and then divided that by 20, so that's going to be the size of each bin that we want. Our first bin is actually going to start at 18.2 because that's the smallest observation we have, and it's going to add to that, the range of the bin is going to be 21.6 units in length. And so the top of that bin is going to be 39.8, and you can see that here because it's basically taking the minimum plus the range. The next bin is then going to go from 39.8, and it's going to add to it that bin range, 21.6, so it'll go to 61.4 and so on and so forth. Now for each of the 4 elements that you do this for, you're going to need to figure out what the min is and what the bin size is going to be, and then start with the bottom, that minimum, and add that bin size to it and update this data in column B. The next piece of it is the count greater than or equal to. So here we've got I have equals count if, so we're using the count if statement, and we're going to refer to P2 to P345, and it says less than or equal to, and B6. So that's going to say this is the count of the number of observations that are less than or equal to 39.8. And you'll notice that there's the ampersand here, and that's just telling Excel that it wants to concatenate less than and equal to, that's in the quotation marks, and the value that's in cell B6. Now what we do is when we click the fill handle or double click the fill handle here to extend that formula all the way to the bottom, you can see it's cumulative, rising up to 344. And so what we need to do to get the actual value, the count within each bin rather than the count below each bin, is to just subtract. We're going to start the first value we know has 80 things in it. The next bin cumulatively has 167, but we know 80 of those are in the previous bin, so we need to subtract out that. So it's going to be 167 minus 80, and then we keep on doing that, subtracting out the cumulative value from the previous bin. And that's going to give us our histogram here. Now the last piece of the assignment asks you to identify on the histogram which samples you think most likely indicate pollution sources. To do that, what I'd ask you to do is simply go to Insert, you can go to Shapes, and there's arrows here, and you can select an arrow and just have the arrow point at the places you think represent observations that might come from nearby potential pollution sources. So that's question 2. We're going to move on now to question 3, Question 3 asks about, says cadmium, nickel, and lead are all on the EPA's list of air toxics that pose the greatest health risks to urban populations. So here we're going to try and find which neighborhoods have the most samples with elemental concentrations of cadmium, nickel, and lead that exceed that 95th percentile value. And then the final part of the question asks you to identify which neighborhoods and districts do you think are most at risk based on the data. Explain your answer and obviously give an Excel explanation. So if you read the hints here, we've actually done this for you. The first hint that identifies whether each of these 3 elements exceeds the 95th percentile concentration for each observation. We're going to use that data, we're going to use a pivot table then with neighborhood names or district names as rows, and the values are going to be the 95th percentile exceedances. So let's look at what that looks like. So we'll go here. We're going to go back to our data set. To do this, you'll see I'm just going to go back up to the top of the data and scroll over here till we get to our percentiles. And there we are. So here you can see, for example, nickel. We have a column next to nickel that has, or the nickel percentile that is called X95 nickel. And the formula that's in here says if AX2, so this is AX2, if that's greater than 95, then we're going to code this cell in AY2. We're going to code it a 1. Otherwise, we'll code it a 0. So the value, if it's greater than 95, is a 1. Otherwise, the value, if it's false, is a 0. And here you can see the result is that the value in AX2 of nickel in that first observation is not greater than 95, and so it gets a 0. And as you look down this vector of data, you can see a lot of zeros, and here we go, there's 197. Right? And we've done this for cadmium and as well as for lead. Right here. Notice that if you can't see the whole title or the data that's in your cell, you can just double click on the edge of the column up at the top of your data set, and it'll expand to the width of that column. Okay, so now we can see each of those exceedance columns, and basically what we want to do here, select our whole data set, and we're going to insert a pivot table, put it in its own new sheet, and we're going to start with neighborhoods. So we'll add the neighborhood names to the rows, and then secondly, let's start with nickel. We're going to add to values the number of exceedances of nickel, and that is going to give us by neighborhood the number of samples that exceeded the 95th percentile.